All right, I want to take a look here at the 2019 micro exam, FRQ number 2. So let's pull it up here. There it is. All right, let me get my pen going. Okay, so this question is, I think, deceptively simple on the front end. Parts A and B are actually not too bad. Part C is where it gets a little bit trickier, and there are a couple key things you need to know or be able to sort of quickly in an efficient fashion, calculate. And there are a lot of calculations in this question. So my best advice here is just to be very deliberate. If you want to use a calculator to make sure, but you don't want to go too fast, right? You would hate to make some silly, computational error, even though you were doing the problem correctly. So, and also pay attention, right? Where they say, hey, we need you to show your work in all these different parts. Definitely make sure whatever calculations you're doing to put those in there on your FRQ. All right, so let's start. So this question is dealing with marginal benefit analysis, and maximizing either surplus, consumer surplus, right, or what we would consider a utility, right? They call it benefit here, but so the following is a table showing Dana's marginal benefit from purchasing bottles of water and this mysterious good X from a grocery store. So we have over here a nice simple table, right? What if this person consumes 1 bottle, 2 bottles, 3 bottles, etc. And then the next column we have the marginal benefit of water in dollars, right? So if you remember back to that part of micro, right? The price of bottles of water may be significantly less than what Dana values it at, right? If Dana receives $24 worth of benefit from this first bottle of water, and the price is significantly less than that, then Dana should definitely consume that, right? And would have quite a bit of consumer surplus. And likewise, we have over here for a good X over here. So let's just start with part A and part first. Which is a pretty straightforward calculation. What is Dana's total benefit from purchasing 2 bottles of water and 1 unit of good X? And again, be sure you pay attention here. Show your work. Let me change that color here. Let's go to blue. Okay, so they give us in this case 2 bottles of water, right? And 1 unit of good X. So we have to add the first bottle of water plus the second, right? We get a little bit less utility from that second one, but we're still adding it. And then we got to consider good X as well. So we're adding 24 plus 18 plus 24. So you add all these up together. Sorry, it's kind of hard to see over there. And you should get a value of $66. All right, so that's a very quick, straightforward calculation. Just make sure, they want you to show your work here, so you're gonna have to show all these different points in there. All right, so let's, we know part C is gonna get a little bit more complicated and difficult, so let's go to part B. Assume the price of a unit of good X is $5. Calculate the total consumer surplus if Dana purchases 3 units of good X. All right, so total consumer surplus. And here we are. Okay, 3 units of good X, so we're over here. And then I want to know the total consumer surplus from good X, right? So consumer surplus is the difference between what I was willing to pay and what I actually paid, right? So anything I was willing to pay above and beyond the figure that I paid, I essentially got a deal, right? I'm experiencing consumer surplus from that fact. So you have to take the difference of all the first, second, and third units here, and then subtract the price, right? So they give us, in this case, good X is $5. So we consumed, or we had 24 minus 5 for this first one, right? Then we had to add 18 minus 5. And then this last one, we're still adding 12 minus 5, right? So let's quickly, what is that? 19, 13, and 7. So you add these up, that's 20, and then plus 19. So we've got 39. And again, you know, if you didn't want to do that in your head, you could do a longhand, or, you know, use a calculator if you have the opportunity to do that. Just you know, be sure you're showing all this work as to what you're doing and how you got at this answer, right? I'm very explicitly, you know, doing this, and then I'm adding all these up together, right? That's what they consider to show your work. Okay, so part B, you should get the answer of $39. And, you know, that's calculating consumer surplus from a table, right? It's no different than, you know, well, it is different, but calculating consumer surplus under a curve, right? You look at that demand curve and see, oh, these people would have paid more, right? But they ended up getting the market price. So you're essentially calculating the area. It's very sort of similar and analogous what you're doing. In this case, it just happens to be more discrete and with a table. All right, so let's try and erase some of this here. Let's just erase everything for now. I don't like that color. Color's not bright enough. Let's try this one. All right. Now we're going to go to part C, and this is where it gets. Well, part one of part C is not so bad, but let's go through it. Now, assume the price of a bottle of water is $3. So let's write that down here. $3 is now the price of water, and the price of a unit of good X is $6. So let's just write that down up here. Dana spends her entire budget of $30 on bottles of water and good X. Now, this is a very key piece of information that you are now given, that if you don't realize it's pretty important, that you could, you know, get lost in this part of this question. So what does that mean? Well, let's just, what's called a budget constraint, right? Because we're going to be trying to maximize benefits and trying to calculate some other things, but we want to know, in order to maximize your benefit, right, you spend your entire budget, right? So the budget here is $30. So what does that mean? Well, let's just use W for water times $3, right? That's how much we spend total on water, plus we're going to have this mysterious good X times $6. And that budget constraint is going to equal $30, right? So whatever combination we end up choosing, water and good X, if you multiply them out by the prices of each, you should get that $30 figure, right? That's a key thing to see later on, especially in parts 2 and part 3. Okay, so part 1, explain why Dana does not maximize her benefit when she purchases 2 bottles of water and 4 units of good X. Use marginal analysis to explain your answer. So if you're lost in this question, they kind of tell you where you should go, right? Use marginal analysis. And so there's a key thing we got to do here. Add a couple of columns to this table up above. And what we want to calculate, so they give us the marginal benefit of each unit, or additional unit of bottle of water, or in this case, units of good X, right? But what we want to do is figure that out, marginal benefits per dollar spent, right? So we're going to add another column here, marginal benefits per dollar. Okay, and what that means, we take this column here, right? They give us the marginal benefit of each additional bottle of water. In this case, each bottle of water costs $3. So we need to divide each of these to fill out this column. We need to divide each of these by the price, right? So 24 divided by 3, so we're going to be 8. 18 divided by 3, 6, 12 divided by 3, 4, 6 divided by 3, 2, and 3 divided by 3, 1. Okay, so we see the decreasing marginal benefit there in terms of price as well. And then we're going to end up comparing that to the same thing. So we're essentially converting these to a common unit, really. Okay, so we know the price of a unit of a good X is $6. So the same thing, we're going to take this column here, each number, and divide by the price of this item, right? So 24 divided by 6, 4, 18 divided by 6, 3, 12 divided by 6 is 2, and 1, and then 1/2, right? Okay, so now what we have is where we need to, in a marginal benefit analysis, right? If you're maximizing, and this question asks about why not, right? Why is this not maximizing? So you need to get, set these equal, right? Find out where these are equal. So, so marginal benefit per price of water, and this is what, good X divided by price of X. So we're comparing these two columns here and seeing if this person is in fact maximizing their benefit. These should be equal, right? So in this case, in part 1, they give us a specific combination, right? So at 2 bottles of water, we go over here to this column and we see 6, right? So at 2 bottles, this is equal to 6. And that should be, if we're actually maximizing, 4 units of good X. So we go to 4 units of good X, and we find that is 1. Does 6 equal 1? No, these are not equivalent, right? So what this is telling us is at this combination, 2 bottles of water and 4 units of good X, Dana would get more bang from her buck, so to speak, from consuming more water, more bottles of water, right? Versus this good X. So this combination is clearly not optimal. So really, this is essentially, you set this, and then if you did the calculations and said, hey, 6 is not equal to 1, as long as it's clear that's what you're calculating, I think that would be a good enough answer. You could also sort of write that out, using words, explain it if you could do so. Now the question is, goes to part 2. Okay, so 2 bottles of water and 4 units of good X are not the optimal quantities. And then, part 2 asks, well, what are the optimal quantities of good X and bottles of water at these prices? Okay, so this is where now we go back to this equation, right? We established in part 1, well, that's definitely not it, right? We were at 2 and 4. Now it's clear that you should consume more bottles of water, right? Because 6 is greater than 1 at that point. So you want to look where these 2 points are going to be equal, right? Now it's a little bit tricky because we have a couple of points on here where these are equivalent, right? We have 4 here, and we got 4 over here. We've got 2 here, and we've got 2 here. And we got 1 here and 1 here. So there are a couple different points on this chart where you would say, oh, if I'm setting these equal here, well, there's a couple of points. So how do I know which one is, the right answer, right combination? Well, all right, so we did, so we definitely know we need more bottles of water. So really the answer, they're not gonna go off the table here. It's gonna be 3, 4, or 5. That doesn't really necessarily help us at all. But the key thing here is this budget constraint up here, right? W times 3 plus X times 6 has got to equal 30. Okay, so maybe we just go through and figure this out, right? So what happens if we consume 3 bottles of water? So that would be what, 9, and 1 bottle of or 1 unit of X will be 6, right? So we only spent $15 if we use this 4 and 4 combination. So if you plug those numbers back into the budget constraint, you should say, oh wait, well there's no way, right? You got to spend your whole budget constraint to be able to maximize utility, right, or maximize benefit. So we're going to throw those numbers out. So let's go to 4 bottles of water, because this is 2 and this is 2, right? So 4 bottles of water and 3 units of good X. And let's just run that quickly against the budget constraint and just see. Let's see, so 4 bottles of water, what is that, 12, 4 times 3, and then 3 bottles, or 3 units of good X, times $6 each, that's 18. All right, add those up. Wow, what do we got? We got $30, okay? And then if you weren't sure, you want to be, extra sure, if you went to this 5 and 4 combination, right, 5 bottles of water, what is that equal to? 15 and 4 units of good X, plus 24, right? So we're way over budget there. What is that, 39? And our budget constraint was 30. So we can't go over budget. So, that's a big clue, right? That tells you you've got to maximize benefit within the budget constraint. So there we are. So your answer should be this combination, right? So 4 bottles of water, 4 water, and what was it? 3 units of good X. And you double check that against the budget constraint, you know that you're good. Okay, so let's go to part 3. Part 3, I think, is the trickiest on here. Because you have to, there's one thing you can calculate quickly, but then the other thing you got to go back and sort of redo your table and sort of calculate. So let's see, go on here. I'm just going to, let's just erase everything. We'll have to redo part of that. But all right, so suppose the price of a unit of good X drops to $3. Calculate Dana's, and let's write this back in here. Before we were 4 water and 3X, right? That was our sort of optimal combination given our budget constraint. So now the price of good X drops to $3. Calculate Dana's cross price elasticity of demand for bottles of water with respect to the price of good X. So we want to know what happens is a change in demand for bottles of water due to a change in price for the good X, and then state whether the 2 goods are substitutes or complements. Again, important things, show your work. They want to see that you know how to calculate this cross price elasticity of demand. Now, if you don't know the formula, right, that's kind of the key thing you got to start with, right? So this is a cross price elasticity of demand. Let's just go like that. What is that equal to, right? So remember, these are our percent changes in the quantity demanded of QD, let's just say of water, over the percent change in the price let's just denote that of good X. So that's sort of your basic formula, right? And if you remember, so a negative number here, we have to actually calculate that, right? Because they want us to show our work. We're going to go to that in a minute. But if you get a negative number, that's a complement, and a positive number should be a substitute, right? So that's sort of what we're getting at here, and they want to know, and they give you that, right? Are they substitutes or complements, and why, right? So we're doing that calculation. All right, so the denominator here is actually not so bad. Percentage change in price of good X. Well, suppose the price of a unit of good X drops to $3. Okay, so now we just need to get the percentage change in price of good X. Let's put this back up here. Initially, it was $6, right? We changed that. Now it's half the price, right? Now it's $3. So percent change, right? Let's do this over here. Let's do it over here. Percent change, 3 to 6, right? 3, the new number minus the original all over the original, right? So we get -3 over 6. You know, if you want to do that in percentage, that is a -50% change, right? Went down by half. So we know, so our original, so we need our percent change in quantity demanded of water. That's going to be all over -50%. Okay, so this is what we're not sure about. We know the original amount of water demanded was 4. And so that's going to be our original. So we're going to have some number minus 4 all over 4, right? Trying to figure out the percent change in the quantity demanded of water. So what we need to do is sort of redo our marginal benefit analysis and figure out what the new amount demanded is at the new prices, right? So if you remember, so the quantity, the price of water was $3. So we got to do this column that we had calculated before. So this was what, 8, 6, 4, 2, and 1. Again, just taking this number and dividing by the price, reconstructing that. Now, before we did this, we divided by 6, right? That was the price. Well, now we got to redo it, right? It changes to a new price. Now, conveniently, right, it's the same price as the other goods. So we have to have the same numbers. Now, again, we're maximizing benefit here. So the key thing in this one, right, is again to bring back in that budget constraint, right? So we're gonna have a new budget constraint because the price has changed. So we've got water times 3 plus X times 3 is going to be equal to 30, right? Anything less than that, we're not spending all of our budget, and we're certainly not going to be maximizing our benefits, right? So think about this. These points are all equal, right? We wanted to set them as we did previously, right, where the marginal benefit per price is equal. Well, they're equal at every point. So that doesn't necessarily help us. But if we think about it in the context of this budget constraint, you know, if I'm going to consume, let's see, our number before was what, 4 and 3, right? Well, those aren't equal anymore because the price changes. So if we did 4, we'd still be at 4. But if you do the quick budget constraint, right, 4 times 3 is 12, plus 4 times 3 is 12 equals 24. Nope, we didn't spend all our budget, right? So there's no way we're going to be maximizing our benefit there. And let's quickly go up. Let's go to 5. 5 times 3 is 15. Oh, look, 5 times 3 is 15, right? Those check out. So there's your new quantity of water going to be demanded at the new price, right? As this column changed over here, we had to do a recalculation, and now our quantity demanded is going to be 5. So now we're going to plug that in to our equation over here. And what is that? That is 1/4 equals 25%, right? That is your change in quantity demanded of water based upon this change in price, quantity change in price of good X, right? So that was the numerator over here. We already did the denominator, right? That was the change in price of good X. So now we need to plug this 25% over here, and we get 25% over -50% equals -1/2, right? So as long as you show your work for that, and then you would have to have, you know, a sentence stating that the two goods are complements, right? And that makes sense, right? So we had a price decrease in good X, and our quantity demanded of the water bottles went up, right? So generally speaking, if things are substitutes, right, and something gets cheaper, I would rather just consume more of the cheaper thing, right? I'm not going to consume more of the thing that's more expensive. So that's why a negative cross price elasticity shows you that things are complements, right? The complements tend to go together. So if the price is decreasing, which it is here by half in this case, but you still consume more, demand more of the other good, right? In this case is water bottles, then these things go together, right? So they must be complements. All right, so that's wraps up that question. Again, deceptively straightforward at the beginning, and then it gets a little bit more complicated there at the end. I think that, you know, parts 2 and 3 of that part C, that's where you're going to separate, you know, the people that are going to end up with a score of a 5 from the people that are going to get a 4 or 3 or lower, right? You know, it's going to trip a lot of people up trying to have to go through those calculations. So be sure you know how to calculate those. And if you're comfortable with this formula, I think that the mathematical calculations are not so bad. The key points of this question are being able to know that you got to create this column, all right, these columns over here. And then I think also realizing this budget constraint is a pretty big important thing. All right.